concentration and pH. So before getting too into it, let's think of all the formulas that we know for when it comes to acids and bases and pH. pH is equal to negative log of hydronium ion or hydrogen ion. Same thing. pOH is equal to negative log OH. I know that pH and pOH is equal to 14. Now I also know that Kw is equal to is equal to hydrogen ion or hydronium, same thing, and hydroxide. And I know that that number is 1.0 times 10 to the negative 14. Alright, so let's look at these problems. Calculate hydroxide for a solution where hydronium is 0.00225 molar. So going back to this equation from the top, I know that water breaks up into, we can even keep it consistent, hydronium and hydroxide. Hydrogen and hydronium are the same thing. Water breaks up into hydrogen, but it reacts back with water, forming hydronium ion. I know that Kw is 1.0 times 10 to the negative 14th, and I know hydronium is 0.00225 molar, and I want hydroxide. So all I do is divide both sides by the molarity of hydronium ion. And the answer then comes out to be 4.44 times 10 to the negative 12 molar. Since it's a concentration, it needs to have the unit of molarity. Now you could have solved this for hydronium, you could have solved for K, it just depends on what you're given. So it's always really helpful to either write out all the equations that you know based off of a certain topic, or look at your equation sheet, write them on the side of the problem, and then kind of just pick apart what you have and what you need. Looking at the next one. What are the concentrations of hydronium and hydroxide in oranges that have a pH of 3.75? Okay, so I also want the concentrations again. This time I'm given a pH of 3.75. Now, like I wrote on the top, pH is equal to negative log of hydronium ion. Well, I want this, and I'm given this. So there's another equation. If you take the inverse of log, which is taking 10 to the power of something, you'd get 10 to the power of negative pH, because your negative sign follows along, is equal to the concentration of hydronium ion. Therefore, hydronium ion is equal to 10 raised to the power of negative 3.75. If you take a moment to plug that into your calculator, you get 1.78 times 10 to the negative 4th. Molarity, because you have a concentration with 3 sig figs. Awesome. Now you have your hydronium and you want hydroxide. So just like from the equation above, you know that hydronium and hydroxide are equal to Kw, and you can do the same thing in isolate. But let's do it a different way. We know pH plus pOH is equal to 14. Since I'm given my pH, I can get my pOH by taking 14 minus the pH. So my pOH will be 14 minus 3.75. And that is equal to 10.25. Now, just like the inverse of log for pH, I can do the same thing for OH, changing up my color. I know pOH is equal to negative log of OH. So then inverse of log will be 10 to the power of something. So I'll have 10 to the power of negative pOH is equal to the concentration of OH. So then I just plug in my values. 10 to negative 10.25 is equal to 5.62 times 10 to the negative 11th molarity. Now, you could have also solved this one other way. You could have said, okay, I know Kw is equal to hydronium and hydroxide. I know that I just solved for my hydronium and I know Kw. My hydronium was 1.78 times 10 to the negative 4th is equal to my hydroxide. And then isolating by dividing the hydronium concentration on both sides should give you the concentration of hydroxide. If you plug that into your calculator, you would get 1.78 fourth, 5.62 times 10 to the negative 11 molarity. So you get the same answer. I showed you this so you know that there's multiple ways of solving it. Now, if you'd given the concentration, you could always just plug it into the negative log and